An enormous range of lengths in the universe, and one straightforward way of discussing these rather than always dealing with exact numbers is to deal with something called order of magnitude. It's a very simple concept. It's basically just the idea of powers of 10. Now, you've already met some prefixes which can simplify this a wee bit, but obviously we run out of prefixes and there's something extra you've got to learn. This order of magnitude is very straightforward. So for instance, if you take something like speed of sound, in scientific form that would be written as 3.4 times 10 to the 2, and therefore we simply say its order of magnitude is 2. The speed of light, on the other hand, would be 3 times 10 to the power 8, so its order of magnitude would be 8. And we would say that the speed of light is 6 orders of magnitude larger than the speed of sound. So basically it means it's roughly a million times larger. But this can be very useful for doing approximate calculations. And the symbol that can be used for it is this called a tilde, but it's a kind of squiggly line. And it gives you an idea of approximately equal to. To give you an idea of some of the orders of magnitude in the universe, we start with the incredibly large. The distance to far quasars, for instance, could be 26 orders of magnitude away. To the next nearest galaxy, to our own, 22. And distance nearest star from the Sun is about 10 to the 17 metres, Proxima Centauri. And to the edge of our solar system, we're talking about 13 orders of magnitude. The Sun, we can think about 2 orders of magnitude here. The radius of the Sun is about 8 orders of magnitude, whereas the distance between the Earth and the Sun is about 11 orders of magnitude. And so on. You get the basic idea as we go from large. Now, all of these incidentally would be 0 orders of magnitude, because if you wrote them in scientific form, it'd be strange things like 1 times 10 to the power 0. Okay, or well, the butterfly would be an exception to that. Suppose if it's a few centimetres, so it would be minus 2 orders of magnitude, so it starts to take us below 0. The width of DNA, 2 nanometers, so its order of magnitude would be minus 9. We'll come back in the waves unit and discuss exact wavelengths for light, but they are all minus 7 orders of magnitude, going from about 4 times 10 to the minus 7 up to about 7 times 10 to the minus 7. The size of a nucleus, for instance, can be around about minus 15, and the atomic radius of helium is quoted as a minus 11. So just to give you an idea of that approximate variation between the nucleus and the atom as a whole. So the nucleus about minus 15, the atom as a whole about minus 11. Okay, so it's about 4 orders of magnitude smaller, the nucleus, compared to the atom. The individual protons that make up are also roughly 10 to the minus 15 helium. Remember, there's only 2 protons, 2 neutrons, so it's similar in size to, or at least in the order of magnitude. We'll go on to talk about what a neutrino is, but you could think of it as being about minus 24. And the smallest possible length, known as Planck length, is about minus 35. So it's just a straightforward idea that you have kind of appreciation of relative sizes, that if you were given a selection of these, that you would know that the radius of the sun is significantly larger than the height of a human being, and so